Someone said to me the other day, I really want to know how to refine copper, and I thought that's a fantastic question because that's exactly what I need to teach. And so what you do is you get a big bucket and you fill it with something useful like copper chloride, which will split into Cu2 plus and 2Cl minus. Okay, and then you're going to get two things. You're going to get a couple of electrodes, one electrode and the other, and this will be 99.99% pure analytical grade copper, and this one here will be like the dirty copper, and we're talking maybe like 96% pure copper. Now impurities get in the way. You can't make highly what's the word for it? Refined special copper wires to run stuff for electrical things if the copper is all dirty. You need the impurities gone, and so you need to force this process, because normally if you stick copper and copper in a solution of copper, nothing happens. But as usual, with an electrolytic cell, you can force this process with a power supply. Hooray! Now in this case here, the electrons are going to go this way, and the following reactions are going to occur. Over here at the dirty copper side, you're going to get Cu solid becomes Cu2 plus plus 2E minus. And those coppers here, they're going to go into solution, so they're going to come off this electrode. The Cu solid here is going to come off and go into solution Cu2 plus. Here coming off as Cu2 plus. And so this electrode is going to slowly start to degrade and get lighter and lighter and lighter. And the coppers will migrate across. Now the electrons will travel down the wire and onto this electrode here, which is highly pure. And what's going to occur here is Cu2 plus aqueous plus 2E minus makes Cu solid, and not just Cu solid but extremely pure solid copper here. And all the impurities of this electrode here, which aren't part of the copper, fall down to the bottom, and this is called anode mud. You might guess that this is the anode. And ox and a red cat, anode oxidation. There's your oxidation there, because you've got the copper solid going to copper 2 plus and 2 minus, so you're losing electrons. There's the oxidation, there's the anode. You can't even see that. See, I wrote anode here. It was out of screen. So that's the anode. And then reduction of the cathode. So you're getting the reduction here of the copper ions, with the electrons becoming copper solid, plating onto this electrode, which is going to get heavier and heavier and heavier with pure copper. And this is the cathode. And electrons flow towards the positive terminal. So again, the anode's going to be positive here. I ought to put this back in the frame. There it is. See, positive for the anode. The cathode here, this can become negative. And I think that's just about everything. Again, a completely messy picture. So if you ever have the need to refine copper, this is how you do it. Also good to know for the exam. Anything I missed there? No, pretty much that's it. In this case here, the chlorine is not coming bubbling out as a gas. It's the copper in itself is taking care of the whole receiving of the electrodes thing, and also electrons thing, and also getting rid of the electrons here. See, if you change this to an inert carbon electrode, yes, the chlorine gas will start to bubble off, but because it's a copper electrode and it's able to come off into solution, the chlorine just stays where it is in solution. Yeah, so that's how you refine copper, a special kind of electrolytic cell.